Happy morning, my dear children. Today our learning objective to learn about metallic character, ionization enthalpy, electronegativity, inertia pair effect, and also allotropes of boron compounds. Allotropes of p block elements. Okay, one by one we can discuss. Please all of you take the note. Dear children, today our learning objectives to learn about the metallic nature, ionization enthalpy, electronegativity, and about that inert pair effect. Question we can discuss that one. So first one about the metallic nature. What is about the metallic nature? The tendency of an element to form a cation by losing an electron is known as electropositive, otherwise metallic character. My dear children, the tendency of an element lose one electron. One of the electron is lost and it achieve a plus charge. Am I right? For example, hydrogen. I am taking one of the hydrogen. Hydrogen lose its electron and it achieve a plus charge. Am I right? That we are saying an electropositive element are metallic characters. Am I right? So this character is depend upon the ionization energy. What is about the ionization energy means I will explain the next topic. Okay. What is about the ionization energy? That is simple concept that the amount of energy is required to remove most loosely bound electron in the gaseous state. Am I right? So I will explain the next one. Okay. Anyhow, here, what happens in the ionization energy in our periodic classification? Okay. Can you understand? What happens the ionization energy, ionization potential, ionization enthalpy, in the periodic classification. Here, the ionization energy down the group it is decreases, and left to right ionization energy is increases. I will explain. Next we have the ionization enthalpy topic. So I will explain that one. So here about one of the 2 mark question, what is an electropositive character? That means the tendency of an element, one of the element, lose its electron and form a cation. That is called what? Electropositive. Example, I wrote that one. Here, you have to learn about p block element present in the periodic classification. That means in the lower part of the metal. Okay, p block element present in the lower part of the metal, while the element in the upper parts are non-metals. Here periodic class, please look at textbook, page number 28. They have one tabular column. I'm writing one of the periodic classification arrangement. Here, they are having 4 colors. I'm right. They are shaded like the 4 colors. One side, they are arranged a blue color. In the middle, they are mentioned like that, green. Then upper, they are like that, something about the violet color like that. The last, they have like just one pink color. Am I right? So each one have different character. For the blue color, it means metals. Green color means metalloids. One of the violet color means it's a non-metal. And the last pink color means radioactive. So the lower part, which are the elements are there. That is about the aluminium, gallium, indium, thallium, tin, lead, bismuth, polonium. These are all what? Metals. What is about the upper part? Upper part means carbon, nitrogen, oxygen, fluorine, neon. About the phosphorus, sulfur, etc., etc. The pink color, violet color. These are all, everything are what? Non-metal. What about the green color? Green color is about the metalloids. Metalloids there is a character between metals and non-metals. Okay. And about the pink color means about the radioactive metals. Here, we can be say about that elements in group 13, the metallic character except the first one is about the boron. Okay, here we can be look the 13th group. The 13th group means the first one element is a boron. Boron is a metalloid. Can you understand? What about the others? Others, which are the other are present there? Aluminium, gallium, indium and thallium. Am I right? These are all what? These are all metal. So the 13th group, only one element, that is about the boron, is a metalloids. Remaining are about that metals. Can you understand? Next about, what is about the metalloids? Having the property between, there's intermediate between metals and non-metals. Okay. Next group, please kind of come to the next group. About the carbon family. The carbon is a non-metal. What about the other two elements? Silicon or germanium, mentioned as green, is a metalloids. Next two are the metal. Tin and lead are metal. Okay. What about the next nitrogen family? Nitrogen and phosphorus are the non-metal. Arsenic and antimony are the metalloids. Bismuth is a metal. What about the oxygen family? Can you see oxygen family? Oxygen, sulfur, selenium. These are all what? Non-metals. T is the metalloids and polonium is the metal. What about the 17th group? Full of non-metals. And about the 18th group? Full of non-metals. Okay, this is about that. About the period, that occupations of P block elements, the metals and non-metals and metalloids. What about that? Next one about the ionization enthalpy. My dear children, ionization energy is otherwise called ionization enthalpy. I am drawing one diagram. For example, sodium atom. What is the atomic number of sodium? The atomic number of sodium is 10. Am I right? Sorry, atomic number of sodium is 11. Am I right? How will you write the electronic configuration? EC is equal to 1s2, 2s2, 2p6, 3s1. Am I right? Otherwise, you can write the K shell. Am I right? K shell, how much electron can be occupied? 2, second shell 8, remaining 1. So, this is the nucleus. Here proton having positive charge. This is the first shell, second shell, third shell. Am I right? First shell we can be accommodate 2 electron. Second shell 1, 2, 3, 4, 5, 6, 7, 8 electron. Third shell having only 1 electron. Listen all of you, my dear children. What is about the ionization energy? The energy required to remove this electron, that means the energy required to remove most loosely bound electron. This electron is most loosely bound. Okay, so we have to remove this electron by adding a small energy, by giving one energy. That energy is called what? Ionization enthalpy. Otherwise we can be say ionization energy. What's the definition? The amount of energy required to remove the most loosely bound electron in a gaseous state. Am I right? So this is about the removing of electron by giving a small amount of the energy, that we are saying ionization energy. So here in the 13th group, 14th group, 15th group, what is about the ionization energy? From top to bottom, ionization energies decreases. From left to right, the ionization energies increases. So what is the reason here? Here, when the atomic size is increases, ionization energy decreases. Don't forget that. Atomic radius or atomic size is increases, ionization energies decreases. Atomic size is decreases, ionization energies increases. Okay, so size is big, ionization energy is less. Size is small, ionization energies increases. Okay, this is about that. Here one more point we have to discuss about that. In group 13, we have discussed one more point. In group 13, boron to aluminum ionization energy is decreases. Am I right? Please look at page number 28. That is one arrangement of electrons: boron, aluminum, gallium, indium, thallium. Am I right? Boron having, I think that nearly 600 and something. Am I right? As we are comparing aluminum, what's the number there? Here, 557. What about the next one? 578. What about the next one? 558. Next, 589. So, boron to aluminum, it is slightly decreases. And aluminum to gallium, a marginal difference. Am I right? A small difference. Next, again expected one. Am I right? Next, slightly again decreases. Okay, again decreases. Next also increases. Am I right? So what is happening here? So what is the why a small difference in there in the 13th group? When we are comparing the 18th group, 17th group, 16th group, 15th group, there is no problem because ionization energy from top to bottom, it is decreases. Only in the 13th and the 14th group having a small marginal difference. Why it is means? It is due to the shielding effect. That means we can be say, while we are writing the electronic configuration of this 13th group, first, that is the boron and aluminum, the electrons present in the p subshell. Am I right? When we are going to the gallium, there will combine d subshell, and indium also d subshell, and thallium also we come f and d subshell. So that's a problem. When the size is increasing, they are having some shielding effect. Shielding. My dear children, what is about the shielding effect? That we have to try to understand the concept, the shielding effect. For example, this is a nucleus, first shell, second shell, third shell, fourth shell. Okay, like that, etc. This is the outermost shell. Imagine like that, it is an outermost shell. The first shell we can be accommodate 2 electrons. The second shell by 6, 7, 8 electrons we can be accommodate. The third shell, suppose I'm occupying the third shell, we can be accommodate as per the 2n square formula, we can be accommodate 18 electrons. Am I right? So as we are accommodate like that. Here, this is the last shell, maybe having only 1 electrons like that. Here, the electron having, what is the charge of electron? Electron having the charge is negative charge. Here, nucleus having proton. What is the charge of proton there? Positive charge. Am I right? Here, positive and negative electrons having some force of attraction. Am I right? Here having some attraction between the proton in the present in the nucleus and having electron present in the shell, outermost shell. Here also, this we are saying the inner shell. Am I right? This shell, we are saying an inner shell. Try to understand the concept thoroughly, neatly. This is an inner shell. So electrons also occupy. What is the charge of electron? This is also negative charge electron. Here also having the negative charge electrons. So here negative charge and here having negative charge, having some repulsion. Okay, due to some repulsion, here having nucleus and outermost shell having attraction. What is the reason? Proton, nucleus having proton, proton having positive charge, neutron having negative charge. So they are having some attraction, force of attraction. Here having electron, here having electron, electron having repulsion. Due to the repulsion, they are having forming a screening. Okay, so that is called what? Screening effect. Okay, don't forget that. Otherwise called shielding, attraction and repulsion. two property having. One is about the attraction. Attraction means proton attract the electron. That is about the attraction. Repulsion means electron, because the electron having negative charge, outermost shell having electrons, and inner shell also having electron. These two electrons are repelling. That effect we called as what? Shielding. Otherwise we can be say screening effect. So that's a problem. We have some marginal difference in the group 13 and 14. Can you understand, my dear children? Okay. So anyhow, the remaining group, that is 15 to 18, they have no problem, as the ionization energy decreases from top to bottom. Okay. So here the poor shielding effect, D and F electrons are overcoming by increase the shielding effect. Okay. So in the third shell, I told that about that 18 electrons are there having. They're having the D and F subshell are overcoming. So increase the shielding. What is about the shielding? Attractions and repulsion. Okay, can you understand? So the ionization enthalpy of successive groups is higher than the corresponding elements in the previous group is expected. So from two groups, first two group, 13 group and 14 group, here ionization energy somewhat having decreasing. Okay. And marginal difference. Next about the electronegativity. It is also same like that. The 13th group electronegativity first decreases from boron to aluminium, and then the marginal increase for gallium. Please look here. They have some numbers are mentioned like that. Okay, about that some values are mentioned like that. You have to understand that one. First decreasing from boron to aluminium. Next, them having marginal increasing for gallium. Okay. Next about the similar trend is also observed in 14th group, also same like that. Here about the electronegativity decreases. Before that, what is about the electronegativity? My dear children, the tendency of an atom decrease to attract the shared pair of electron towards itself. I am giving one of the example. Any one example I am giving. For example, chlorine. Can you example chlorine? Cl. What is the atomic number of chlorine? 17. Am I right? 17. First shell we can be accommodated 2 electrons, second shell 8 electrons, third shell 7 electrons. Am I right? Here also first shell 2 electrons, second shell 8 electrons, third shell 7 electrons. Am I right? First I am drawing the first one chlorine. This is the nucleus of a chlorine. Am I right? Proton. And first shell, second shell, third shell. First shell having 2 electrons, second shell having 8 electrons, third shell having 7 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 7. Okay, 7 electrons. What about the other chlorine? First one 2 electrons, second one 8 electrons, third shell other 8 electrons. Am I right? Other 7 electrons. Okay, 7. So anyhow, this chlorine is attract the shared pair of electron towards itself. Can you understand? For what purpose? To attain the stable electronic configuration, that is 2, 8, 8. Can you understand? For getting this 2, 8, 8, this chlorine attract the shared pair of electron towards itself. And also, this chlorine atom also attract the shared pair of electron towards itself. So that is we are saying about that electronegativity. Okay, what is that one? Electronegativity. Here, top to bottom, electronegativity increases. Okay, top to bottom, electronegativity decreases. Okay, from left to right, electronegativity is increases. Top to bottom, electronegativity is decreases. Left to right, electronegativity is increases. So left to right means, for example, suppose what happened, the left to right means number of proton in the nucleus is attract the outermost shell, because left to right the size is decreases. Am I right? The atomic size is decreases. For example, if I am taking carbon, atomic number of carbon is how much? 6. First shell 2 electron we can be accommodate. Second shell how much electron? 4 electron. Am I right? 2. Now center part of the proton. This proton will be attract this carbon. Am I right? Sorry. Proton will be attract to the outermost electron present the carbon. So what happens? Here the size is very small. So they are having a very attraction between the outermost shell and also electron present in the shell and also the proton. Suppose it is happen to the top to bottom, the size is increases. So the electrons outermost shell electron and the center of the nucleus proton charge is very far away. Am I right? Very high distance. So if the distance is more, electronegativity is decreases. Okay, if the distance is high, that is electronegativity is decreases. So we are saying top to bottom, the atomic size is big size. Am I right? So the electronegativity is decreases. Next about, we can be discussed what are the anomalous properties of the first element. What are the anomalous properties of the first element? My dear children, they have in 3 points are given in the textbook. One is about that first element, anomalous properties of the first element. That means group number 13, group number 14, group number 15, group number 16, group number 17 and 18. This is the first element having some anomalous properties. What is that one? One is about that small size. First element having the small size. That is the first member. Boron to neon, the size is very small. Okay, as we are comparing the second element. As we are comparing second element means aluminium, silicon, phosphorus, sulfur, chlorine, argon. As we are comparing the first row and second row, we are saying that the first element are small size. The first element having, due to the small size, high ionization energy and high ionization electron enthalpy having. Okay, high ionization enthalpy and high electronegativity having. Okay, the first point is small size, the first, because they are occupying the first is, am I right? First having the small size, first member of this element having the small size. Second, they have high ionization enthalpy and high electronegativity. And about that, they're not having d orbitals in the valence shell. They have only p orbital. Am I right? P subshell. Am I right? Yes or no? They have, what is the electronic configuration? ns2 nb6. Am I right? That is ns2 nb126. ns2 nb126. They have no d subshell. So absence of d orbital in their valence shell for the first member of the group 13 to 18. As we comparing here, that means thallium, lead, bismuth, polonium, etc. They are having the d subshell. We are comparing to the boron, carbon, nitrogen, oxygen, fluorine, neon. They are having no d subshell. Okay. Next, the first member of group 13, boron is a metalloid. Okay. The first member of 13th group, boron is the metalloid. Other element are reactive element. That is, we are saying metals. Metals are more reactive. Am I right? Reactive element. Which are the other element? Aluminium, gallium, indium, thallium. Okay. Here, boron show a diagonal relationship between silicon. Okay. Because boron is a metalloid, they have some diagonal relationship between silicon. Because silicon is also, what is about that? Metalloid. Can you understand? So they are used as a semiconductor. So silicon is used as what? In semiconductor. And oxides of boron and oxides of silicons are similar because they are acidic in nature. Okay, why they are similar? Oxides of boron, oxides of silicons are where? In acidic nature. Okay. Then boron and silicon form covalent hydrides, they can be easily hydrolyzed. Okay, here except we are saying boron trifluoride, except boron trifluoride it is not hydrolyzed. Okay, next group number 14, we can be discuss about the group number 14. The first element carbon, the first element is carbon, is the non-metal. The other elements are metalloids. Example, silicon and germanium are the metalloids. Okay, and some of the metals have in tin and lead. Okay, and here carbon can form multiple bonds. For example, carbon carbon double bond, carbon carbon oxygen bond. Okay, and also we can be say one more point, one of the very very important point. Carbon has a great tendency to form a chain of bond, that we are saying catenation. Am I right? Carbon bond with other carbon, carbon bond with other carbon, other carbon, carbon other carbon, like that we get one of the big chain compound. Am I right? Big chain, that we are saying catenation. Okay, and about in group 15, the first element nitrogen differs from other element. What is about that? Like carbon, nitrogen also can form multiple bonds. For example, nitrogen double bond, carbon nitrogen double bond, nitrogen oxygen double bond, nitrogen triple bond. Okay, and also nitrogen is one of the diatomic gas. It is one of the diatomic gas. Others are, for example, phosphorus. Others are non-metals. Okay, non-metals. And tin are the metalloids, bismuth is the metal. Okay, what about the 16th group? Oxygen. Oxygen is one of the 16th group. It is also diatomic, that is a O2. Okay, why means it is due to its high electronegativity bond, hydrogen bond. What is about the hydrogen bond? For example, I am taking water, H2. What is the formula for water? H2O. Oxygen can bond with hydrogen, oxygen can be bonded with hydrogen. Okay, this is make what? Hydrogen bond. Okay, bonding of hydrogen. Next about the first element of group 17, it is a non-metal remaining. And also here one more point, fluorine forms hydrogen bond like oxygen. Okay, fluorine also bond hydrogen bond with like oxygen, because what is the reason? Fluorine is the most electronegative element. Fluorine shows the -1 oxidation state. I told that it can be, fluorine can be accept an electron, so -1 oxidation state. Other halogen may be other halogen. We discussed that on other halogen. That means in the absorbed yesterday portion, other absorbed oxidation state for the halogen, which are that one +1, +3, +5. Am I right? And +7 oxidation state in addition to -1. Fluorine is the strongest oxidizing agent and the most reactive element among halogen. My dear children, next one is about that. We can be discuss about that inert pair effect. One of the 2-mark question, important 2-mark question. What is about that inert pair effect? Okay, that means here ns electron is not bonding. Okay, that's the meaning, the correct ns2 nb6. We know that the p block electronic configuration and general electronic configuration, general formula ns2 nb6. Here the ns2 is not involving for the bonding. Only which one is taking part bonding? P. The p one is p subshell. It is only making for bonding. That is about that inert pair effect. Okay, try to learn this question. Okay, my dear children, here inert pair effect here means, inert means not involving bonding, not involving bonding, that we are saying inert pair effect. Pair means 2 electron. What is about the pair? Pair means 2 electron. Inert means not involve bonding. Pair, so 2 electron not involve bonding. Can you say, my dear children? 2 electron not involving bonding. That is about the inert pair effect. Here the alkali and alkaline earth metal having oxidation state is +1 and +2. Am I right? Alkali metal means hydrogen, sodium, potassium. These are all what? Alkali. Am I right? What's the reason? What's the reason we are saying alkali metal? What's the reason we are saying? Because it can be donate one electron. Am I right? One electron. What about alkaline earth metal? We are saying that on beryllium, magnesium, calcium, strontium, barium. These are all what? Alkaline earth metal. Okay. Okay. So it can be donated 2 electrons. So the oxidation state is +2. Am I right? Yes or no? What are the alkali metal? Alkali means hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. This outermost shell having only 1 electron. So it can be donated. So its oxidation state is +1. Suppose 2 means oxidation state means +2 because it can be lose 2 electron means +2. 1 electron means +1. So anyhow, here as per the P block elements, they also show some variable oxidation state. Here we are using the heavier post-transition element. Heavier post-transition element means we are saying about the D block elements and F block element. Am I right? So we can be discussed that time. Okay, that means the next lesson we have about that D block elements, that we can be discussed about that. Anyhow, it belongs to group number 13 to group number 16. The most stable oxidation state is less than is 2. Oxidation state is 2. It is less than the group oxidizing state. So what is the meaning here means? Here, as we are taking boron, what is the group oxidation state of boron? +3 oxidation state. What is about the 14th group? Is a +4 oxidation state. What is about the 15th group? +5 oxidation state. What is about the 16th group? +6 oxidation. Like that they are increasing. Am I right? So each one having some variable oxidation state. So my dear children, here what is the explanation means? Heavier post-transition metal, the outer S electrons have tendency to remain inert. Previously I told that Ns to Np6, here the Ns electron, outer Ns electron have a tendency to remain inert. Inert means not reacting, and show reluctance, that means unwilling to taking part in the bonding. This is known as about that inert pair effect. Okay, so try to mark that line, that paragraph, the last 3 line. In the heavier post-transition metal, the outer S electron Ns have a tendency to remain inert and show reluctance to taking part in bonding, which is known as inert pair effect. This effect is observed in group number 14, 15, 16. This is enough. Okay, only for the 2 mark question. My dear children, next our topic is allotropism in P block element. Allotropism in P block, very important area. Okay, this is the very important area. Try to learn this question today. Okay. Some element exists in more than one crystalline or molecular form. One crystalline form or one molecular form. Can you understand? The same physical state. Here carbon exists, diamond and graphite. The phenomenon is called allotropism. In Greek, allo means another. Tropy means change. One form change into another form. That is one crystalline form change into one molecular form. Okay, we can be simply say they have different forms. Some element exists different form, that we are saying allotropism. Okay, allo means another, tropy means change, another change, one form change into another form. Here some of the common allotropies are boron. Boron exists 6 allotropic form. What is about that? Amorphous boron, amorphous boron. Okay, alpha rhombohedral boron, alpha rhombohedral boron, alpha rhombohedral boron. beta rhombohedral boron, beta rhombohedral boron, gamma orthorhombic boron, gamma orthorhombic boron, alpha tetragonal boron, alpha tetragonal boron, beta tetragonal boron. These are the 6 allotropic form of boron. Next about the carbon. Okay, carbon exists 5 allotropy. One is about the diamond, graphite, graphene, fullerenes, carbon nanotubes. This is one of the book bag question. Try to learn. Carbon, so exists 5 allotropy. One is about that diamond, graphite, graphene, fullerenes, carbon nanotubes. Next about the silicon. Silicon exists 2 allotropy. One is about that amorphous silicon, crystalline silicon. Next about the germanium, alpha germanium, beta germanium. Next tin, grey tin, white tin, rhombic tin, sigma tin. Grey tin, white tin, rhombic tin, sigma tin. Next about the phosphorus, white phosphorus, red phosphorus, scarlet phosphorus, violet phosphorus, black phosphorus. Next arsenic, yellow arsenic, grey arsenic and black arsenic. Antimony, blue, white antimony, yellow and black antimony. Oxygen, dioxygen, ozone, sulfur, rhombus sulfur, monoclinic sulfur, rhombus and monoclinic. Selenium, red selenium, grey selenium, black selenium, monoclinic selenium, monoclinic selenium. Last one, tellurium, amorphous and crystalline. So all of you learn this question thoroughly. Today our assignment is same question. Dear children, once again we can be discuss about the most common allotropies of p block elements. First element is about the boron, having 6 common allotropies. Number 1, amorphous boron. Number 2, alpha rhombohedral boron. Number 3, beta rhombohedral boron. Number 4, gamma orthorhombic boron. Number 5, alpha tetragonal boron. Number 6, beta tetragonal boron. Second one, carbon element exists to 5 allotropic form: diamond, graphite, graphene, fullerenes and carbon nanotubes. Silicon exists to 2 allotropic form: amorphous silicon and crystalline silicon. Germanium exists 2 allotropic form. First one is about that alpha germanium. Second one, beta germanium. Next about the tin, exists 4 allotropic form: grey tin, white tin, rhombic tin and sigma tin. Phosphorus exists 5 allotropic form: white phosphorus, red phosphorus, scarlet phosphorus, violet phosphorus and black phosphorus. Okay, once again, white phosphorus, red phosphorus, scarlet phosphorus, violet phosphorus and black phosphorus. Arsenic, yellow arsenic, grey arsenic and black arsenic. Arsenic exists 3 allotropic form. One is about the yellow arsenic, grey arsenic, black arsenic. Antimony exists 3 allotropic form. One is about the blue white antimony, yellow and black. blue, white, antimony, yellow and black. Next about the oxygen. Exists two form. One is about that dioxygen and ozone. Sulfur exists two form. One is about that rhombus sulfur and monoclinic sulfur. Selenium have exist four allotropic form. Red selenium, grey selenium, black selenium and monoclinic selenium. Tellurium exists two form. One is about amorphous and crystalline form. Okay, so my dear beloved children, please all of you try to learn this most common allotropic forms. It's very very important. Try to learn this. This only one question is enough. Okay, today you have to learn thoroughly, learn and write. Okay, if you have any doubt, please call me. Okay, please take it. Thank you all of you. Thank you. Have a nice day.